lilac color is provided by the K positive. So just look at the compound which contains potassium. Potassium iodide is the responsible. Forms a cream precipitate when aqueous solution reacts with the acidified aqueous silver nitrate. Silver nitrate is generally used to test the presence of halides, either chloridine, bromidine, or iodine. Aqueous silver nitrate that will produce the white PPT with chloride, cream PPT with bromide, and yellow precipitates with iodide. So cream precipitates are produced by the bromidines when they are reacted with the aqueous silver nitrate. Just look at the substance which contains bromide. So sodium bromide is the substance because that contains bromide. So sodium bromide is the answer. Is an acidic oxide. Generally, the non-metal oxides are acidic. Sulfur dioxide, nitrogen dioxide, they are the acidic oxides. So in the list, if you look at the substances, sulfur dioxide is there. So sulfur dioxide is acidic oxide. Then is an unsaturated hydrocarbon. Unsaturated hydrocarbon, which contains double covalent bond between carbon to carbon, and the ending code must be "ene" or the suffix must be "ene." As we can see that the propene is there, so propene is unsaturated hydrocarbon, is a product of incomplete combustion of fossil fuel. By the complete combustion, we will get the carbon dioxide. By the incomplete combustion of fossil fuel, carbon monoxide will be the product. So if we check our list, carbon monoxide is the answer. Is used to test the presence of water. There are generally two compounds which are used to test for the water. Number one, anhydrous cobalt copper 2 sulfate, and the second one is anhydrous cobalt 2 chloride. So if we check in the list, we have hydrated cobalt 2 chloride that is not used. Anhydrous cobalt 2 chloride is used, which will give the color change as blue to pink. And the second reagent is anhydrous copper 2 sulfate, which will give the color change white to blue. So anhydrous copper 2 sulfate is used to test the water. Okay, just look at the next question. Table 2.1 gives information about particles A, B, C, D, E, F. So these are the some particles, and the number of electrons, protons, and neutrons are shown in the front of every particle. Give the letter of all the particles which are atoms. So if we look at the atoms, so atom must have the same number of electrons and protons. So just look at the particles in which the protons are exactly equal to the electron. If we look at the A particle, as you can see that the protons and electrons are equal, so A is an atom. Then look at the B particle, electrons and protons are equal, so B is the atom. C, 10, 13, no. 18, 16, no. 18, 17, no. 15, 15, yes. So if the electrons are equal to the protons, then that particle will be the atom. Ions with the two negative charge. Two negative charge. If you want to get the two negative charge, it means that the particle must have two more electrons than protons. So if you look at the different particles which are in the table 2.1, we can say that D, it has 18 electrons and 16 protons. So every proton is positively charged particle, so plus 16, and every electron is a negatively charged particle. So if we look at the E has negative 18 plus 16, so we will get negative 2. So the E is, D is the particle because D contains the 18 and 16. Okay, so D is the particle which contains 18 electrons and 16 protons. So D is the answer. Cation. Cation is a positively charged ion, and cation must have more protons than electrons. So just look at the number of protons and electrons. As you can see in the C, that C contains 13 protons and 10 electrons. So if protons are more than electron, then particle will be the cation. State the atomic number of A. Atomic number is the number of protons present in the nucleus. Number of protons. So just look at the number of protons. How many protons are present in the A? A contains 5 protons. So 5 is the atomic number of A. Determine the number of nucleons in the D. Nucleons mean P plus N. So just add the two particles, protons and neutron in the D. Protons are protons in the D. There are 16 protons and 17 neutrons. So if we add 16 plus 17, 16 plus 17, there are 33 nucleons. State the electronic configuration of D. Just look at the D. What is the proton number of D? D is 16. 16 is the proton number, but it has 18 electrons. So we'll have to distribute the electrons because in electronic configuration, you have to distribute the electrons. So if this particle has 18 electrons, so it will be like 288. State the group number of the F. So group number can be identified from the electronic configuration and from the valence shell electrons. So if we look at the atomic number of F, or the proton number of F, F is 15 because F is the atom. So if we do the electronic configuration of F, having 15 proton number, it is 285. So 5 electrons are present in the outermost shell of F. So that's why the group number of this F is fifth. It is the fifth group number. State the uh, period number of B. So period number of B is concerned with the number of shells. And again, the number of shells can be predicted by the electronic configuration. That look at the proton number of B, B 10, and then electrons are also 10. So this is atom. So if we do the electronic configuration of 10 to 8 is the electronic configuration, and there are two number of shells. So that's why uh, the period number of B is second. It is in the second period of the periodic table. Okay, now in the next question, this question is about the nitrogen and some of its compounds. So nitrogen is converted into the ammonia in the Haber process. Nitrogen is obtained from air. State the percentage of nitrogen in the clean and dry air. Almost 78 to 79% of the nitrogen is in the air, so 78%. Still state the source of hydrogen for the Haber process. Natural gas is the source of natural gas is the source of hydrogen. Natural gas reacts with the steam to form hydrogen gas. Now, the Totten cross diagram, uh, there is a molecule of ammonia which contains one nitrogen and three hydrogen atom. So nitrogen has 5 electrons in its outermost shell. So just make the 5 electrons, 1, 2, 3. 3 are busy with the hydrogen, and 2 electrons are not taking part in the bonding, but they are in the outermost shell. Every hydrogen has just 1 electron in its outermost shell. So 1 electron, 1, and 1. So this is the dot model of nitrogen. Nitrogen, 5 electrons, each hydrogen, 1 electron. Write a chemical equation for the reaction occurring in the Haber process and give the typical reaction conditions. The two gases, nitrogen and hydrogen, they react with each other to form ammonia. So this is ammonia. And there are two nitrogens, so we can put 2 here, 6 hydrogen, 6 hydrogen. The different uh, conditions, the temperature, it must be 450 degrees Celsius, pressure 200 atmospheric pressure, or in kPa, 20,000 kPa. Iron is the catalyst which is used in the Haber process. So these are the some conditions of the Haber process. The next part, ammonia is converted into nitric acid. So this is a chemical equation which is used to uh, get the nitrogen monoxide. This is a series of there are series of reactions. So this is the first step, that ammonia combines with oxygen to get nitrogen monoxide and water. The forward reaction is exothermic. So this is exothermic. It is then the reverse reaction must be endothermic. And if the forward reaction is exothermic, the overall reaction is also exothermic. Now, which of the following element is most likely to be used as a catalyst? So the this property that they're used as a catalyst, this is the property of transition element. So you have to identify the transition element from the list. Calcium is not a transition element. Lead is it is also not a proper transition element. Sodium, sulfur. Sulfur is a non-metal. Sodium is also in the group 1. So platinum is the element which is the proper transition element. So platinum is used as a catalyst. State the oxidation number of nitrogen. Here we have the two elements, nitrogen, plus there are three hydrogen, and the sum of oxidation state is 0. So the rule for hydrogen is that hydrogen has +1 oxidation state except with metal. If hydrogen is along with the metal, it has -1. So hydrogen, if it is +1, so to make it 0, we must add +3. So +3 is the oxidation state of -3. -3 is the oxidation state of nitrogen. Here you can make a -3. So -3 is the oxidation state of nitrogen in ammonia. And O, so there is one nitrogen, one oxygen, 0. Oxidation state of nitrogen is -2. So if we add +2, we will get 0. So +2 is the oxidation state of nitrogen in nitrogen monoxide. Use your answer to 2 to explain whether the nitrogen in the ammonia undergoes oxidation or reduction. So just look at the oxidation state or oxidation number. Here, the nitrogen is -3, and here it is +2. So there is an increase in oxidation state or oxidation number. So increase in oxidation state is oxidation. So this is oxidation, and because oxidation state or oxidation number, nitrogen increases from -3 to +2. So this question is regarding rate and yield of the product. So effect on the equilibrium yield, nitrogen monoxide is on the right hand side, and the effect on the rate of the reaction. So this is regarding rate and this is regarding yield. So in this reaction, you have to apply the concept of shifting of equilibria, because this question is regarding equilibrium yield, and this question is only concerned with the rate of the reaction. So decreasing the pressure, if we decrease the pressure, effect on the equilibrium yield. So for the pressure, just look at the number of moles of gases on both sides. Decreasing the temperature. So if you are looking at the effect of temperature on the equilibrium yield, just look at the enthalpy change and look at the number of moles of the reactants and the product. We have 5 plus 4, 9 moles of gases on the left hand side, and 6 plus 4, 10 moles of gases on the right hand side. So if we increase the pressure, the equilibrium shifts from more moles to less moles. And if we decrease the pressure, the equilibrium shifts from less moles to more moles. So we are decreasing the pressure, so equilibrium shifts from less moles to more moles. Equilibrium shifts to right, and if equilibrium shifts to right, the nitrogen monoxide is on the right hand side, so yield increases. Then decrease the pressure as the forward reaction is exothermic. So if we decrease the equilibrium shifts to right. Again, this will also increase. Removing the catalyst. Catalysts have no effect on the equilibrium yield, so we can say that no effect or no change. Now, on the rate of the forward reaction, when we decrease the pressure, definitely the rate will also decrease. So the rate decreases. Uh, Describing the temperature causes the rate of the forward reaction to decrease. Explain using collision theory. So we have to explain on the basis of this collision theory why the rate of the reaction is slower at the decreased temperature. If we decrease temperature, the kinetic energy of the particles that will also decrease. Kinetic energy of particle, sorry, kinetic energy of particles decreases. And due to the decrease in kinetic energy, we can say that the frequency of collisions between particles is lower because now there are less number of particles have energy equals to or more than activation energy. Activation energy is the minimum amount of energy which is required to start the chemical reaction. So the particle must have the energy equal to or more than activation energy, then that particle will be able to convert it to the product. So there is a second stage of the nitric acid preparation. So balance the symbolic equation for the reaction. So if we want to balance this chemical equation, there are two hydrogens. So we can put two here. If we put two here, then two nitrogen, we could put two here. So first of all, if we put two here for the hydrogen, then there are two nitrogen. We can put two here. So there are six number of oxygen atom on the right hand side. So two plus two, four. And if we put two here, so if we balance the oxygen atom, then there are four hydrogen as well. So we have to make it four. So if we make it four here, so we'll have to change the complete equation that we have to make the nitrogen 4 as well. So there are four nitrogen atom. Then to balance the oxygen atom as well, 4 times 3, 12. So 4 to 6 and then 6 more. So 6 plus 4, 10 plus 2, 12, 4 times 3, 12, 4 hydrogen, 4 hydrogen, 4 nitrogen, 4 nitrogen. So this is the balanced chemical equation. Okay, now this question is about sulfuric acid and salts that are made from the sulfuric acid. So zinc reacts with the dilute sulfuric acid. Aqueous zinc sulfate is one of the product, and this is the aqueous zinc sulfate. Powdered zinc is added to the dilute sulfuric acid and the mixture is stirred. More zinc is added with this stirring until the zinc is in excess. So zinc is in excess. The mixture is then filtered, named the limiting reactant. If zinc is in excess, the second reactant is the limiting reactant. So this is dilute sulfuric acid. So the examiner says name, don't write the formula, just write the name. State two observations that indicate the zinc is in excess. So if zinc in excess, definitely a time will come when solid remained undissolved. So if the solid remained undissolved, it means that it is in excess. And the second thing is there is a observation of hydrogen as well, that the hydrogen produces bubbling. So if there are no more bubbles or no more bubbling, or we can say the bubbling or the effervescence, if it stops, there is no more reaction. Name the filtrate. Filtrate in the form of salt. So this is the zinc sulfate. Then name two compounds which both react with the dilute sulfuric acid to produce aqueous zinc sulfate. So this is the general property of acid, that acid reacts with the metal carbonate, metal oxide, and metal hydroxide to produce salt plus hydrogen. But a metal can also react with the acid to produce salt and hydrogen, but copper is below hydrogen in the reactivity series. So copper doesn't react with the sulfuric acid to give salt and hydrogen. So generally, we can use the zinc oxide or zinc carbonate, or we can also use the zinc hydroxide. So here, actually, we're using the zinc metal. Okay, so these are the reactants which may be used along with the sulfuric acid. State why it is, what is meant by the term saturated solution. The saturated solution is the solution which contains the maximum amount of the dissolved salt at a particular temperature. The solution contains maximum dissolved salt at a particular temperature. Explain why crystals form when the saturated solution cools down. Solubility is concerned with the temperature. So if we decrease the temperature, the solubility of the salt decreases. So solubility decreases as we decrease the temperature. Solubility decreases by decreasing temperature. The next part is regarding the molar calculation. So we have a salt, nickel 2 sulfate. This is hydrated nickel 2 sulfate, and it is heated. We will get the anhydrous nickel 2 sulfate plus water. So these are the different steps. The nickel 2 sulfate crystals are weighed. Then nickel 2 sulfate crystals are heated. Remaining solid is allowed to cool. Remaining solid is heated again. Then repeat it until there is no change in mass. State the term used to describe crystals that contain the water of crystallization. So hydrated compounds generally contains water of crystallization. So the term which is used, that is hydrated. State why step 4 is repeated until there is no change in the mass. This is the step 4. So the remaining solid is heated again, allowed to cool, and then wait. This is heated to ensure that all the water of crystallization is removed. So to ensure all the water of crystallization is removed. This is another part of the question that in an experiment, 0.454 gram of nickel 2 sulfate, they are heated. This is the hydrated, and we're getting the anhydrous nickel 2 sulfate plus water. So the mass of hydrated nickel 2 sulfate is 0.454, and the mass of anhydrous nickel 2 sulfate is 0.310. So we can calculate the mass of water as well, 0.454 minus 0.310. Now look at that question. Calculate the number of moles of nickel 2 sulfate. So we have nickel 2 sulfate remaining. This is the remaining. So we have the mass, and we have the MR as well. So the mass is 0.310 and divided by 155, which is 0.002. Calculate the mass of water given off. So we have 0.454 grams of hydrated nickel 2 sulfate and anhydrous is 0.310. So the mass is 0.144. Calculate the number of moles of water. Now we have the mass and we have the MR as well. So the number of moles in water is 0.144 divided by 18. So we will get 0.008. This was 0.144 and this was 0.002. Now we can use the value of nickel 2 sulfate and uh, water to calculate the value of X. So NaSO4, 0.002 moles are there. So 0.008 moles are there. Just simplify by dividing with the smallest number. So this is 1 and this is 4. For every 1 mole of nickel sulfate, there must be 4 moles of water. So that's why the value of X is 4. And the formula of hydrated nickel 2 sulfate is NiSO4.4H2O. Then this question is about iron.